Okay, in this video lesson, we are going to be looking at solving ratio questions. We're going to do that by using a tape or the strip diagram. One of the reasons we're doing that is because we are expected to represent ratios and percents with concrete models. So I want to show you some models. We will also see fractions, and I'll show you equivalent fractions, and we will also take a look at examples of ratios as multiplicative comparisons as well. So we'll see a lot in a couple of examples here. Let's go ahead and take a look at the first one. So in this example one, it says that a recipe for pizza dough calls for 2 teaspoons of salt for every 3 cups of flour. How many teaspoons of salt will be needed for 18 cups of flour? Now, the word ratio doesn't appear in here, but the 2 teaspoons of salt for every 3 cups of flour, that is a ratio. Let's go ahead and diagram that ratio. Let's just draw 2 teaspoons of salt would be represented by that diagram, and then 3 cups of flour could be represented by that diagram. If you just want to remember, you might want to identify that this is our salt and this one is our flour. Okay, now in our example, it says that if you know this ratio, then how many teaspoons of salt will be needed for 18 cups of flour? Well, let's just look down at our diagram and we understand that this is going to need to be 18, our flour. Well, if that's broken up into 3 parts based on our original ratio, then 18 divided by these 3 parts is going to be 6. Well, since we have this ratio, the 2 parts of salt has to be 6 as well. So when you combine these 2 6s, you get a total of 12. So our fraction or our ratio now is 12 to 18. And we realize that the answer, how many teaspoons of salt will we need, is the 12. Okay, this is our answer here. Now let's just take a look at that. Let's just take a look at it as equivalent fractions, or let's look at the multiplicative comparison. Okay, the original ratio again was 2 teaspoons of salt to the 3 cups of flour. Well, we were told that the flour was going to be 18 cups. Obviously, we're making lots of pizza dough. So if we're going to use 18 cups of flour, and we want to keep this ratio equal so that the pizza dough turns out the same way, what we can do is just try to identify this relationship here, this multiplicative relationship. If we go from 3 to 18, what we're doing is multiplying times 6. Maybe I should do that in green so that you see the 6's that match this 6 with these 6's over here. And then, of course, if we multiply the teaspoons of salt times 6 as well, 2 times 6 is the 12. And that is how we come up with the answer, 12 teaspoons of salt based on 18 cups of flour. Okay, let's take a look at another example here. It says that last night the Sugar Shack sold 3 ice cream cups for every 7 ice cream cones. If they sold a combined total of 250, how many of each did they sell? Now, before I go ahead and work this one out, I want you to remember that sometimes ratios are given to us as a part. We're comparing 2 parts, but we can also have ratios that compare a part to a whole. And we'll be looking more at a part-whole relationship in this example. Alright, so let's take one more look at it. Last night the Sugar Shack sold 3 ice cream cups for every 7 ice cream cones. Okay, let's go ahead and model that real quick. So we have the 3 ice cream cups, and then we have 7, and I'll try to make this look like it makes sense. 1, 2, 3, 4, 5, 6, and 7. Okay. Okay, so our diagram takes care of the two parts. The 3 to 7 is the original ratio. But in the question it says if they sold a combined total of 250, how many of each did they sell? So in the last example, we increased one of the parts so we could figure out the other part by the same increase. But in this example, we have an idea of a new total. Okay? Well, it doesn't specifically give you a total, but if you look at the ratio 3 to 7, we actually have a total. Just count up all the parts. 1, 2, 3, plus 4, 5, 6, 7, 8, 9, and 10. 3 plus 7 is 10. So we do have a total here in our diagram of 10. Well, we want to use that and understand that when we add up all our parts, we have a total of 250. Well, if we need all of this to equal 250, and we have a total of 10 parts, we can just do some division here. We can divide 250 divided by 10, and we're going to get 25. So we understand now that what we're going to do is increase our parts, the two parts that were given, by 25. Because if we were to draw this diagram 25 more times, if we did this exact diagram 25 more times, we'd end up with 250 parts. But I don't think anyone wants to draw that much. So let's see what it looks like to just use the diagram and understand the multiplicative relationship. Okay, so again, if we know that we have a whole of 10 in our original ratio of 3 to 7, when you add that together, you get 10. But we know that we're going to multiply times 25 so that we can get a new total of 250. Well, what we're going to do is we're going to take this 25 and we're going to put it in all of these parts. So we have 3 25s up here, and we have 7 25s here. So now we can just determine how much we have of each one. 25 times 3 is going to be 75. And then 25 times 7 is 175. So we have 75 ice cream cups and 175 ice cream cones. And when you add those together, you'll get 250. So these are your two answers. 75 would be the cups, and 175 would be the cones. Okay. Now, I also want to show you this in terms of a percentage. If we were to draw this ratio of 3 to 7 as just one total, where we have all 10 parts together, we remember that 3 of them were represented by the cups, and that 7 of them were represented by the cones. So we could say that 3 out of 10 represent the cups, and that 3 out of 10 represents the cones. Well, the 10, remember, is the whole, so this is a part to whole ratio. You know what, I realized I made a mistake here. This is supposed to be a 7 out of 10, but that represents a part out of whole relationship as well. And I would like to know that you know the percentage without even knowing how many cups total were sold. You know that the cones were 70%, because 7/10 equals 70%, and then we know that the cups were 30% because 3/10 represents 30%. So just using the same kind of model, putting it together to show you percentage. Okay, so that's a look at representing ratios and percents with concrete models.